Hey, Wiz Takers, happy Friday. I know we do not have any requirements today. I hope you're taking today off since it is Good Friday. But I did just want to post the answer keys to the documents this week. Check it out today. Check it out on Monday whenever you have some extra time. Hello, hello. Excited to be here with you today. Take a look at Dixie's sweater. She is styling the pink knitted sweater here as it started to snow. And I thought we could share with you a few of her outfits. Dixie is now styling as a penguin. Notice little waddle here, and it's got her little scarf to keep her warm. This is her attire that she wears when it is awfully chilly outside and lots of snow on the ground. She tends to really enjoy it. And next up, we have Dixie's polka dotted sweater. She has a nice little stylish bow. She's got all four legs in the sweater. You may think, how cruel, putting your dog in sweaters? She hates that. No, she actually goes over to her little basket and pulls out the sweaters to let me know she wants one. No more sweaters in her outfit drawer, but we do have this nice scarf. Notice it looks a little like space for science, just trying to support me in my subject area. And lastly, Dixie has a nice little rain jacket here for when it's wet outside and rainy. We don't like her to come in all damp. So this nice little rain jacket has a nice little stripe. It actually has a little hole here for her leash to go right through because the hood goes right over the ears, just like that. She doesn't really like the hood, if I'm being honest, but there it is. There's Dixie. Look at that. Oh, strut your stuff, Dixie. Nice job. And that is it. Those are just a few of her outfits. All right, and there you have it, Dixie's fashion show. Thanks for watching. I'm going to start with the roller coasters assignment from Monday. So hopefully you can see my screen here. Number 1 said roller coasters use its gravity to move the train around the track. That's what brings it down the hill. When does a roller coaster begin to store potential energy? It's storing potential energy as it's moving up. The farther and farther away from the ground it goes, the more potential energy that it's growing. So you think of gravitational potential energy, which you learned this week, just means the farther and farther away it is, gravity's pulling harder and harder to try and keep it down. So 3, gravity pulls the train down the tracks, which continues to increase the acceleration and velocity. 4, the roller coasters move faster with the more kinetic energy it has. So the more kinetic energy that's flowing, so that's why the larger the roller coaster hill, the faster you go down it, and the more energy you have. Friction is the reason roller coaster is able to become to a stop, just like a ball, just like a bike, anything that comes to a stop, that friction is involved. Law of conservation of energy is basically saying that energy is never destroyed, it is transformed. So potential energy doesn't lose, it's not losing, it's not going nowhere, it's transferring into kinetic energy, and then it's transferring back to potential energy, or maybe it's transferring to friction and that's why it's coming to a stop. Why do you think the first hill of the roller coaster is always the largest? Well, at the highest point, you have the most potential energy, and it creates that energy to then get through the whole roller coaster. What happened to PE and KE as the train travels around the roller coaster? It converts back and forth through the hills. So then when we moved into number 9 here, we were looking at this picture, and the first question says, where's the roller coaster create the most potential energy? We said that was the largest hill, the farthest away it is from the ground. Number 2, where's the roller coaster create the most kinetic energy? That would be at the bottom of the highest hill because it had the most energy going. So that would be B, at the bottom of the biggest hill. Where's the roller coaster would create the second most amount of potential energy? That would be the second highest hill, and that would be E. Someone asked me this week about what about in the middle? So if you are halfway down the hill, that means it has half potential energy and half kinetic energy, because it has it's in between as it's transferring from potential to kinetic. So at the very bottom of the hill, it has the most kinetic energy gained as it would, or as it could. If we keep going down here, we're starting to talk about gravitational potential energy, talking about the farther and farther you go up, higher you go up a ladder, the more potential energy you are storing. It also has to do with the mass. So if you take a look at my picture here, you have the coconuts and the apples. Well, coconuts have more mass than apples. So an apple and a coconut might be at the same height, but the coconut has more mass. So its gravity's working harder to keep it here. So that coconut has more GPE, or more gravitational potential energy. All right. And we are going to move on to our second assignment that we did on Wednesday with graphing. So a real quick recap: independent variable is something I, as the experimenter, gets to set. Dependent variable is something that depends on what I picked. So that's what's changing because something happened. And your control variables between every group that's doing the same thing. What's everybody doing the same so that our data stays the same? Number 4, we talked about the dentist, and the independent variable, something that I chose, would be the types of toothpaste. So that would be the Crest and the Oral-B. Then you have your dependent variable. Because I picked those different types of toothpaste, the whiteness of my teeth is going to depend on the toothpaste that I'm using. And then the things that need to stay the same would be, we're brushing the same amount of time. So 3 minutes, set your timer. The amount of toothpaste you're allowed to use, the type of water. We're checking every week, not every 2 weeks. So the time frame would be the same. For number 5, you were supposed to look at this typing speed graph. The dependent variable is on the y-axis, which is going up, so that's word per minute. And the independent variable is along the x-axis. That's weeks of practice. So I, as the experimenter, am picking how many weeks of practice I'm going to give you, and then the words that I get depend on how many weeks that you've been given. And lastly, for number 6, you're looking at a turtle's pace, and we're looking at a time and distance graph. So how much time I give the turtle depends on how far it's going to go. So the independent variable is I chose when I'm going to stop the stopwatch. The dependent variable is when I stopped that stopwatch, how far did the turtle get? So hopefully you were able to draw out your graph, and I will be posting a picture of a finished graph for you to compare.